You're listening to the Bare Metal Cyber Prepcast, created to help you succeed in your IT Fundamentals certification journey. Learn more at baremetalcyber.com, where additional prepcasts, books, and training materials await. Let's get started. In this episode, we will focus on how operating systems store, organize, and protect data using file systems. A file system is not just a background component. It is a critical structure that allows your computer to keep track of where data lives, how it is accessed, and who can use it. We will explore three major areas tested on the IT Fundamentals Plus exam: compression, encryption, and file types. These topics help you understand how data can be made smaller, kept secure, and organized into meaningful categories for system access and user productivity. This content is covered in Domain 3 of the IT Fundamentals Plus certification and appears under the section dealing with operating system components and file management. Questions on the exam may ask you to identify file extensions, explain the purpose of compression, or recognize how encryption protects data. You will not be expected to configure these settings manually, but you do need to understand what they do and how they affect files on a system. Mastery of these basic file system concepts will support your understanding of broader operating system functions and exam success. A file system is a method used by operating systems to organize data on storage devices like hard drives, solid-state drives, or flash memory. It determines how files are named, how they are stored, and how the system retrieves them. Without a file system, a drive would be just a collection of raw data with no order or structure. File systems allow the creation of directories or folders, maintain information about each file, and ensure that applications and users can reliably access the data they need. There are many different types of file systems used by various platforms. FAT32 and exFAT are common on removable drives and are widely compatible with both Windows and Mac OS. They are useful for simple storage, but lack advanced features like permissions. The NTFS file system, used by most Windows systems, supports large files, encryption, and detailed access control. On Linux-based systems, ext4 is the most common file system, offering reliability and journaling features. Understanding which file system a device uses helps determine what features are available and how data is managed. File compression is a method used to reduce the size of files so they take up less storage space. It works by identifying and removing patterns or redundancies in the file's data, creating a smaller version that still contains all the original information. Compressed files must be decompressed or unpacked before they can be used normally. This means that while compression saves space, it adds a step to the process of accessing the file. Several file formats are commonly associated with compression. Zip and RAR are two of the most popular, often used to bundle multiple files together into a single compressed archive. Other formats like .gz or .7z are also used across different platforms, especially in Linux and software development environments. These file types are frequently used for backups, software downloads, or transferring large datasets because they simplify storage and delivery. Compression offers several advantages in daily computing. First, it saves disk space, allowing more files to be stored on a device or drive. Second, it can speed up file transfers over a network, especially when dealing with large files or slower connections. Finally, it is helpful for archiving, where space is limited and immediate access to every file is not necessary. These benefits make compression an essential feature of modern file systems and file management practices. File encryption is another key concept, especially in security-focused environments. Encryption transforms a file's contents into an unreadable format that can only be decoded using a specific key, password, or digital certificate. This ensures that even if the file is accessed by an unauthorized person, its contents remain secure. Encryption is widely used to protect sensitive or personal information. Examples of encryption in action include encrypted folders in Windows that require a login to access, secure email attachments that can only be opened by the intended recipient, and full disk encryption used on laptops to protect data in case the device is lost or stolen. Some operating systems offer built-in encryption features, while others rely on third-party tools. Regardless of implementation, the core concept remains the same: keeping data safe by making it unreadable without proper authorization. File types are identified by their extensions, which are the suffixes that appear at the end of a file name. For example, .docx indicates a Word document, .jpg represents an image, and .exe refers to an executable program. The operating system uses these extensions to determine which application should be used to open the file. If the extension is unknown or missing, the system may prompt the user to choose a program manually. Some systems hide known extensions by default, which can make identifying file types less obvious. Understanding the categories of file types is helpful both for everyday use and for exam preparation. Common categories include text files like .txt, image files like .png or .jpg, executable files like .exe, and archive files like .zip. Audio files such as .mp3 and video files like .mp4 are also common. Spreadsheet formats like .xlsx are used in office environments. Being able to recognize these types quickly helps with file organization and troubleshooting tasks. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. Files within a computer system are stored using a structure of folders and directories. A folder is a container that can hold files or other folders, creating a hierarchy that helps organize information. This structure allows users and applications to locate data using a defined path. For example, on a Windows system, a document might be found at c:\documents\reports. On a Linux system, the path might look like /home/user/documents. These paths act like roadmaps, guiding the system to the correct file on the drive. Each file in a file system is assigned one or more attributes that define how it behaves and who can access it. Common attributes include read-only, hidden, and system. A read-only file cannot be edited unless its attribute is changed. Hidden files do not appear in standard folder views unless specific settings are enabled. System files are essential to the operating system and are usually protected from modification or deletion. These attributes can be viewed and adjusted through the File's Properties menu in most operating systems. File permissions are a more advanced but critical part of file system security. Permissions determine what actions a user or program can perform on a file. These include the ability to read the file, write or modify it, and execute it if it is a program. The NTFS file system used by Windows supports detailed user and group-level permissions, allowing administrators to assign access rights precisely. These controls are vital for preventing unauthorized access or accidental changes to important files, especially in shared environments like offices or classrooms. When naming files, there are certain restrictions and rules that users must follow. Most operating systems limit the length of file names and prohibit the use of special characters such as /, *, question mark, and angle brackets. These characters are reserved for system functions and cannot appear in file names. In addition, some names like CON, PRN, or NUL are reserved words in Windows and cannot be used as file names. Following these naming rules helps prevent file errors and improves compatibility across systems. Case sensitivity refers to whether the operating system treats uppercase and lowercase letters in file names as different. In Windows, the file system is usually case-insensitive, which means that file.txt and file.txt are considered the same file. However, on Linux and Unix-based systems, these two names would refer to separate files. This distinction is important for users working in mixed environments and may be included in exam questions to test your understanding of cross-platform behavior. Basic file operations like copying, moving, and deleting are handled by the operating system's file manager. When you copy a file, the system creates a duplicate in another location. Moving a file removes it from one place and places it in another. Cut and paste is one method of moving, while copy and paste duplicates the file. Deleted files may go to the recycle bin or trash, where they can be recovered, or they may be permanently erased depending on the action taken. Understanding these operations helps manage files safely and effectively. Operating systems provide tools to view and manage file properties. These properties include the file's size, type, creation or modification date, and permission settings. Accessing file properties can be done through a right-click menu or system utility, depending on the operating system. Reviewing these properties allows users to determine if a file is current, who last modified it, and whether they have the rights to open or edit it. Properties also help with sorting and organizing files in large directories. On the IT Fundamentals Plus exam, you can expect questions that focus on identifying file types by their extension, understanding how compression and encryption affect files, and matching attributes or permissions to specific usage scenarios. For instance, a question may describe a file that is locked for editing and hidden from view, prompting you to identify the associated file attributes. Other questions may present examples of compressed or encrypted files and ask about their behavior or requirements. Being able to interpret these characteristics accurately is key to answering correctly. It is also important to understand what is not expected on the exam. You will not need to configure advanced file system settings, mount or unmount storage devices using command line tools, or edit registry values. The exam focuses on recognizing and understanding common file concepts, including compression, encryption, file types, attributes, and permissions. This approach ensures that all candidates have a basic grasp of how data is organized and secured without requiring in-depth technical skills or administrative experience. To conclude this episode, remember that the file system is responsible for how data is stored, accessed, and managed within a computing environment. Concepts like compression help reduce file size, encryption ensures security, and file extensions indicate type and function. Attributes and permissions define how files behave and who can interact with them. A clear understanding of these topics supports your success on the IT Fundamentals Plus exam and forms a strong foundation for further studies in operating systems and data management. Thanks for tuning in to the Bare Metal Cyber Prepcast, your trusted source for cybersecurity news and insights. Remember to subscribe at baremetalcyber.com so you never miss an update. And visit cyberauthor.me for best-selling cybersecurity books that equip you with expert knowledge. Until next time, stay secure and stay vigilant.